Okay, so today we'll have a very interesting presentation, I think, on frequent words are semantically more stable than rare ones, relational modeling, corpus analysis, and psycholinguistic databases can tell us about lexico-semantic change. And this will be presented by Baumann, who is an assistant professor of digital linguistics. That's very interesting. Digital linguistics at the Department of German Studies at the University of Vienna. He was visiting scholar at the University of Stellenbosch and the University of Berlin, and he's a lecturer at the Adam Kiewicz University in Poznan, as well as a guest researcher at the Austrian Center of Digital Humanities and Cultural Heritage. Having a background in linguistics, mathematics, and cognitive science, he does research on modeling language, the evolution and change. And Andreas combines techniques from mathematical ecology and evolution, as well as methods from the field of data science and corpus linguistics. He was co-PI in 2 projects on lexical in German, and his PI on the project, which examines the relationship between digitization and linguistic diversity. And you, and then we need to do some software around the PI. Okay.
Also, critical thanks, thanks a lot for the introduction and for being here in the first place, not only digitally but also physically. This is great, and in particular in such a great place. We don't have such a beautiful botanical garden in Austria. So this is very special. And second, actually, I need to apologize for the title. In a nutshell, it's I will be going to talk about the relationship between frequency and semantic change. And when I talk about when I refer to semantic change, semantic change, well, so lexico-semantic change. Okay, so what is this going to be about? To give you a very good or example, when nowadays you say to someone, this part of English, this would be a reaction. Someone would say that, right? In most instances, they need to do this. However, let's travel a couple of centuries back, and let's say you say something like that. Thou art Lisa. In later English, that is called the reaction that you get, and this is because in later English, neither something like silly. So this would be an insult. And another question is why do we see that words actually change their meaning? Okay, so the thing is, as you might know, words change their meaning whenever they're used in normal contexts. There are different aspects of lexico-semantic change. There are words that like in the example of night, so become more positive, they feel more negative. But what words also do is something very demanding, and they obtain additional sense, right? Additional meaning. And for example, the word net, usually, so formally, refer just to the word soup, or some kind of soup, some semi-liquid food or meal. Nowadays, we can also go to bacteria or living water, and it can even use verbally. Another question is which factors actually drive semantic change, and this is actually the main question that I want to talk about. And one of the factors, oops, there is a and now, and one of the factors that have that law is yes.
I just see a lot of comments from people in the chat that the sound isn't good. So okay.
I'm muted.
Test. Yeah. Okay, is it better now? Any comments? Yes. Okay. Then I will try to use this one here. I hope that the microphone is sensitive enough when I move to the slides, but we will see how this works. All right. Okay. So the one factor that has actually been examined a lot, and that I also want to look at, is that of utterance frequency. And one idea that comes from cognitive linguistics is that cognitively entrenched words, so routinized words, words that are used very often, resist change more easily. And there is actually sort of a seminal paper by Pendleton and colleagues. It's now already 8 years old, almost. And this is about the rate of semantic change and how it relates to frequency. And the main result is the one that you see here on this plot. So here in this room, you can actually see this axis here. So the horizontal axis actually is frequency, and the vertical axis rate of semantic change. And the thing is, they have looked at the behavior, the semantic behavior of thousands of words based on corpus data. And what they found is that there is a negative effect of frequency on the rate of semantic change. So this means more frequent words are semantically more stable than less frequent words. And this is one thing, so this is an observation that I want to look at more closely, and that I want to examine in more details. Okay, so to give you an idea of what the simultaneous behavior of multiple words looks like, let's have a look at this graph here. I do not want to go into all the details, but what you need to know is that this triangle here sort of represents a share of the semantic space for a set of words. In this case, it's only words with 3 units and 1 morphem. So exactly 3 units. The lines here in this plot, in this triangle, refer to semantic movements. Okay, so every color indicates one line, and each line refers to a single word. Okay, and if there are very long lines, then there is a lot of semantic movements, and if there are if the lines are clumped together, so to say, then words are more stable. Okay, so this is what you need to know right now. I will go into the details of what this is based on data, but this is the picture that you get when you get frequent words.
So you get a couple of words concentrated in the middle of the semantic space, a couple of them on the boundaries. But there are also a lot of blank spaces, so to say. But the interesting thing is when you don't look at frequent words, but at rare words, the picture looks very different. Okay, so when you look at rare words, you see that the long is actually going on. And now the big question is why this is the case, and whether these are effects that we can only see when you look at I don't know, long-term developments, or maybe also in short-term developments. Okay, so this is the menu for today. What I want to do with you together is having a brief look into three studies that I was that I've been working on in the past couple of years. All of them are about the role of utterance frequency, lexical frequency. The first one is going to be about the relationship between frequency and semantic variability. So this means how the tendency to fluctuate in the semantic space. The second study is going to be about frequency and semantic diversification. So the tendency to become more polysemous, to obtain more meanings. And the third study, this is, in a way, also work in progress. This is about the interaction of frequency and lexical acquisition in semantic variability, diversification, and what we call displacement or semantic shift. So whether words travel a lot in the semantic space. Okay, the data methods that I will use are the following. So I will use a lot of digitized data from text data, from English and German. I will also use psycholinguistic databases. Actually, in the research that I will show to you just one of them, namely a database of lexical age of acquisition ratings. So this is first language acquisition data, only for English. In terms of the methods that I use, I will draw computational modeling of lexical semantics, but also some computational modeling, population dynamics that are very briefly, and so it's a technical analysis of semantic change. So this is what I want to cover today, and let's see how it looks time-wise. Maybe I need to skip some parts, so we will see. And please interrupt me when I need to stop. All right. Okay. So let's have a look at the first study. So this is about the relationship between frequency and variability. Now the determinant study that I have referred to a couple of minutes ago, 2016, this actually dealt with the development of English words based on the corpus of historical American English, which covers actually 2 centuries, so 200 years. And the question that we asked ourselves was whether we see the same effects, so the same conserving effect of frequency, also when you look at the shorter time scale. We did so by examining a corpus of German, more specifically Austrian German. So we took the Austrian media corpus, which basically covers all the print and online media that exists in Austria. It's pretty huge. It covers. Sorry. Okay. Thank you. So it covers 20 years in total, and it's in total about 11 billion words. It is prepared to some extent, although we also needed to do some additional pre-processing. But yeah, this was a bit annoying. But what else can you do? In our case, we didn't look at all the words in the corpus, but at a balanced set of words, roughly 3,000 target words. and the data set is balanced with respect to frequency, growth, and fluctuation. So we have frequent and infrequent words, they are growing and declining words, and fluctuating and relatively stable words. So when I say fluctuating, I mean that a word is sometimes used in one context and sometimes in a different context, and then again in another context. And when you have a stable word, then it's a word that is pretty much always used in the same situations. Okay. This corpus actually has a high temporal resolution. So we had enough data to train word embeddings for monthly subcorpora. This was nice. So in the end, we had one word embedding, one vector representation per month per word in our data set. So you see that when you look at this graph here, you see that the monthly corpus size is something between 20 and 40 million words tokens, which is great. I don't know how many of you are familiar with the concept of word embeddings. It's in a way a numerical representation of the meaning of a word. Nowadays it's those numerical representations are computed through deep learning models, but essentially this is just a vector of, I don't know, maybe 100 dimensions, 100 entries, or maybe 300 entries, and the logic behind it is that the more similar the meaning of a word is, the closer of two words are, the closer the corresponding vectors are also to each other. So that's the underlying logic. So words that are used in similar contexts and hence are argued to have similar meanings, also have similar vectors, so similar numerical representations. And this is what we use here. So what do we do with this? With those word vectors, we construct lexical networks. So for each target word and each month, we compute a so-called ego network based on the similarity between the neighboring vectors. And what you see here is, for example, the network of the word transparent in 1 month in our data set. You see that there are a couple of words associated with the word transparent, and you sort of also see some type of clustering that some of the words in this network refer to colors and things like that. So transparent means that you can see through something, but transparent also has the meaning that I don't know. It's that you don't have any secrets in I don't know, processes of employing someone or something like that. Interestingly, so for transparent, for example, in Austrian German, we found that this is a novel development that we actually only can observe in the past 15 years or so. And before that, this the second meaning, not referring to colors, actually wasn't very widely used. Interesting. Okay, now for each target word in our data sets, we computed monthly distances between consecutive networks, and then semantic variability is sort of computed as the average distance. So you count, you compute how long those or how distant those networks are from each other. Okay. So this is how this was measured, and then we simply fitted a model of variability depending on frequency, and we also controlled for a couple of other factors like network size and part of speech tags, so adjective, noun, or verb. And the result is that there actually is a robust negative effect of frequency on semantic variability. And what we found interesting was that this effect that was formally reported based on data that come from 2 centuries is actually also observable when you only look at a very short period of 20 years. This means that semantics is actually very sensitive to frequency. Yeah, note that this negative effect of frequency is not present in small networks. Yeah, we can maybe discuss afterwards why this might be the case. Maybe it's an artifact of the method, but yeah, we can discuss this afterwards. There is actually no substantial effect of part of speech on semantic variability, so no differences between word classes. Okay, so resume number 1, frequency inhibits variability. Okay, let's go to the next study number 2, the relationship between frequency and semantic diversification. So the thing is, as all of us know, words typically have multiple senses. I don't know if there are any words that have only a single sense, actually. I guess polysemy is the norm rather than the exception. But the question is why this is the case, and a very simple answer is, well, those senses must have emerged over time, right? Otherwise, they wouldn't be here. And as an example, let us have a look at the word mess. So I told you before that for a very long time, the only meaning of the word mess was actually a portion of semi-liquid food. And then only after some centuries, additional meanings have emerged, or meaning clusters. So one is related to food. So having one's meal with a particular person, a building in which food is provided. So a mess where initially only soldiers had food, but now actually everyone can have food in a mess. Or in general, a company of people eating together. And on the other hand, we also have the meaning of simply a quantity of milk or food, so a measure of quantity, and then more generally, just a large amount and quantity of something. Okay, but what we also got was this more negatively associated set of meanings. So a situation that is confused and full of problems, making something untidy or dirty, a dirty state of things, or even some, and most recently, to mishandle an enterprise, so to mess up something. Okay, and now we wanted to know why words actually obtain more meanings, and what the role of frequency is in this development. And for this, we combined a set of different data sets. All of them are English, so from German to English. So one is by Hu et al. From 2019. It's a data set of sense distributions for about 3,500 words. And the data that they have used to compute those sense distributions is, first of all, the Oxford English Dictionary, and second, the Corpus of Historical American English, again, covering 200 years. So what they did was they took the sense descriptions and sense examples as presented in the Oxford English Dictionary. Then they trained a sense disambiguation model, and then they used this model for every single word to detect which senses are how frequent in every single decade in the Corpus of Historical American English. Okay, so this was the first data set. The second data set is a diachronically layered data set of pre-trained word embeddings. This is actually the very same data set that Hamilton and colleagues have used. So you can easily compare our results against theirs. We also took frequency trajectories that we directly retrieved from the Corpus of Historical American English, again, covering 200 years. All right. Now, first of all, since we are talking about words obtaining more meanings, we needed to measure sort of a tendency to diversify meaning. So we needed to answer the question, to what extent did the word get more senses over time? And actually, there are a couple of ways of measuring this, and we checked 3 of them, A, B, and C. I will show you C in a second. A is simply counting the number of senses per decade based on the sense distribution data set. The second option is measuring diversity of the sense distribution for each decade. So, for example, when you look at the 1850 data point, you see that there is one very dominant sense and a couple of others that are substantially less frequent. So in that case, you would have not a lot of diversity, right? There is one very, very dominant. But when you look at the further development, look, for example, at the 2000 data point, then you see that there is much more diversity. So there are other senses also present at roughly, I mean, not exactly, but roughly the same frequencies. We simply computed the entropy of the sense distribution for every single decade to measure diversity. And when you have roughly the same frequencies for your senses, then you have a higher entropy, but there is one very dominant sense, you have lower entropy. Okay, so this is A and B. And for C, we actually did something related to the semantic network approach that I've shown to you before. So when I was talking about the Austrian German data. So here we looked at the intransitivity of the lexical network for each target word per decade. So how does this work? So first of all, we took word embeddings for each word. Then we constructed again an ego network for every single word. Here, for example, you see the ego network of the word mess. So all of these words are connected to the word mess. And then we looked at the clustering coefficient of this network. So what is the clustering coefficient? It essentially measures to what extent neighbors of one target node are connected to each other. If all neighbors are connected to each other, then you have a very high clustering coefficient. If you have a star-like network topology where you have one node in the middle and only lines, a single line, every single neighbor, then we have a very low clustering coefficient, or actually a clustering coefficient of 0. Oh, all right. And then we took 1 minus C. So 1 minus the clustering coefficient as polysyny. So in a nutshell, the more star-like the network topology, the more meanings there are. So this is the logic here. And it's actually the same logic that also Hamilton and others apply. All right. Okay. Now, so this is how we measured polysyny. So how did we actually measure the tendency to diversify meaning? So for each word, we measured sense diversity, the number of senses, and intransitivity for every single decade. So you see this here in those graphs here for the word mess. And for each of the 3 measures, A, B, and C, sense diversity, number of senses, intransitivity. And then we simply fitted regression lines, so linear models, because that's the most simple thing that you can do. to each of these time series, and then we took the slope of those time series of those linear models as the tendency to diversify. So this was the most general thing that we could come up with. Okay, but you have but the advantage is that you don't have a single measure, but 3 measures, and this in a way makes your computation a bit more robust. Because we would expect that for all of these measures, we have actually the same diachronic behavior. Okay, frequency then was measured by simply looking at the historical frequency trajectories. This was not very spectacular. What is more interesting is that there is a robust negative effect of frequency on the tendency to diversify meaning, and this applies to all of the 3 measures. So we have a consistently negative effect of frequency on the tendency to become more polysemous over time. Resume to A, frequency inhibits diversification, but the usual question is why? Okay, and so the thing is, the models that I've shown you here are statistical models, are essentially just correlation. So they do not tell you anything about causality. And that's a bit sad. So what can you do? You can employ mathematical models, which you set up in exactly the one way that you like them to be. You can integrate those mechanisms that you found most plausible or most interesting, and you can measure the effects of those mechanisms on the long-term behavior of them. And this is what we did. So here I used a population dynamic model approach, ordinary differential equation approach. So we're talking about populations of speakers. What you see here on this photograph is Shibuya crossing in Tokyo. I don't know if you know it, but actually it is one of the crossings with the largest amount of people actually sort of passing it and using it. Per phase, you have 3,000 people using this space, which is impressive when you see it. Why did I show you this? Well, the thing is, words are actually used by lots of people, right? And words spread through populations of individuals that communicate with each other. Words are not something abstract that is isolated somewhere in a meaning space or something like that, but they're actually used and passed on. And this also applies to meanings. What we did here was we looked at a population dynamic model of the usage of a single semantic variant of a word that depends on a semantic property that we let's call it X in a population of speakers. So, for example, the word could be mess, portion of food, and the semantic property that we look at could be valence. So valence going from negative to positive. All right. Then what we do is we allow for the emergence of competing semantic variants of the words. Let's call it Y. So then you have X and Y. And Y could be the word mess, meaning a disgusting portion. So portion of food with a more negative meaning. And now the idea is that you analyze the predictions about the resulting long-term behavior of the semantic properties. So whether, for example, the average valence of a word gets higher or lower. Okay. So on the next slide, I will show you what the model equation looks like. So we have an equation that looks like this for every single word and every single word variant. I think it's not really necessary to go into the details here, but what this shows is, on the one hand, that we model the change in the number of uses of a word variant, You see this here on the left-hand side. And this rate of change depends on a bunch of other things, and that's the important part. So we have frequency in there, we have a parameter in there that refers to learnability. Learnability depends on semantics. We know this. There are also other factors that make the model more socially more realistic. So there is a bias to behave in a conformist way, so to adapt to other people. There is a bias to behave in a non-conformist way, so to sort of behave in an extravagant fashion. There are parameters that account for the facts that meanings need to be discriminated from each other, and so on. So there is a parameter accounting for discriminability, and all of this is squeezed into this model. So you need to believe that all is done correctly here. But what you can do with this model is you can investigate the tendency to which the model will predict that there is a stable coexistence of multiple senses. This refers to so-called branching points in the semantic evolution of the word. And you see an example of branching here in this model. So you have in the beginning you have just one meaning, and then the meaning splits up into two meanings that stably coexist. And you can show that they stably coexist. So this is not something statistical or so that you derive, but those are analytic solutions. And so the main result is that at low frequency, we get these branching points. But when frequency is high, it is actually not that likely to get those branching points. So this means that high frequency yields stable senses, preventing those splitting events. Yeah, the thing is, I've talked about causality before. The great thing is the model can tell us about some of the causes because we can look at the parameters and their effects on the evolutionary behavior. And according to the model, the reason why high frequency words yield stable or are not very likely to have those branching points is that they correspond to stable states, actually evolutionary bad ends or evolutionary optima in the meaning space that optimize for transmission. So what the model tells us that high frequency words are actually those that are transmitted very easily, and since they are transmitted very easily, they are sort of immune to those branching processes. So they are sort of immune to invasions that can create those stable coexistence of multiple meanings. Okay, what we also see is that this is actually only true if there is a high enough tendency to behave in a non-conformist manner. So if everyone behaves in a conformist manner, or a large enough fraction of people, then you will also not get a lot of the semantic diversity. All right, so this is a resume 2b. So frequency inhibits diversification, and this is because frequent words are transmitted. So that's what the model shows. All right, and now I already come to the final study number 3 about the relationship between frequency and acquisition. So we've talked about lexical transmission a couple of minutes ago, and one aspect of lexical transmission is also acquisition, right? I mean, we can transmit words in everyday conversations, but we also transmit words in the process of first language acquisition. And now what we asked ourselves was in which way frequency and acquisition interacts and have an interacting effect on the semantic development of words. In other words, is the frequency of is the effect of frequency modulated by ease of acquisition? Yes or no? And for this, we use psycholinguistic data, namely a database compiled by Cooperman, Mark Brisbane and colleagues, that features subjective age of acquisition ratings of actually, I think, 13,000 English words. They also have the same data set for Dutch, if I remember correctly. But the English one is the biggest that they have. So what is a subjective age of acquisition rating? This might sound a bit shady, but what they actually do is they ask a lot of people at what age they have, for example, acquired the word miss. So it's purely subjective and introspective if you want. But by averaging across a large enough sample of individuals, you actually obtain estimates that are that correlate highly and come very close to estimates that you get when you observe children directly. So those data are reliable. It's a very interesting method. Those data are gathered through crowdsourcing efforts. They are with thousands of people, and it seems to work nicely. And the great thing is that for this, that using this method, you can get the data for thousands of words. Okay, and we just took their data and used them. Here you see those plots again, and what now you actually already know what they are based on. So what they show is those sense distributions that I've shown that I've used in the second study. So those are the sense distributions that are based on the Oxford English Dictionary and the CogSci English. And at the bottom, you see the behavior of frequent and rare words. This is what you've seen already. And here at the top, you have those triangles correspond to early acquired words and late acquired words. For the sake of illustration, I've just shown you the top 50 and bottom. But what you see immediately is that what is going on in those triangles it actually is very different from each other. So early acquisition is not the same as being frequent. You have very different patterns. Yeah, and so the question is in which way frequency and acquisition now interacts in their effects on the semantic evolution. Okay, so here we didn't just look at a single aspect of semantic evolution, but at 3 different ones. So we wanted to disentangle different properties of semantic evolution, semantic dynamics. One is again diversification. So 2 words become more polysemous over time. And a diversification process actually, when you look at this triangle, corresponds to a movement into the center. When you go to the center of this triangle, then this means that every single sense is going to have roughly the same frequency. Whereas if you are in one edge, in one corner of this triangle, then this means that you have predominantly one meaning. Maybe a bit of another as well, but predominantly one. So this is diversification. So diversification corresponds to movement to the center of this triangle. We looked at displacement also. So what is displacement? So this is how far words travel in this semantic space, in this triangle. And finally, we also looked at variability. This measures to what extent the meaning of a word fluctuates in this triangle from one period to the next. And please note that variability and displacement is not the same, because I could fluctuate a lot and pretty much stay on the same place all the time. Then I have high variability but low displacement. So those 2 processes are not the same. All right. Okay. And our findings so far are the following. So that frequency has a uniformly demoting and stabilizing effect on the semantic dynamics. and this is independent from acquisition. So we fitted again regression models, including an interaction term, frequency and age of acquisition. In none of the models where we found that this interaction term was statistically robust, so statistically non-trivial. We did find that frequency always increases decreases semantic dynamics, semantic dynamics. But interestingly, the effect of age of acquisition is more complex. Because what you have is that early acquired words show less variability and less displacement. So we have those effects. And this, in a way, corresponds to what you would expect when you look at frequency. But when you look at diversification, you actually get the opposite effect. So early acquired words are more likely to diversify their meaning than late acquired words. And yeah, there might be a couple of reasons why this is the case, related to metaphorical extension, for example, could be also. And yeah, and one effect or one variable that we also controlled for was concreteness in another set of models. So how concrete or abstract the word is. Actually, we found that including concreteness doesn't matter. So the effects of frequency and age of acquisition remain even if you integrate concreteness. All right, so resume number 3 is this: frequency demotes semantics, even if acquisition is control core. And this is already my final slide. So frequency inhibits semantic variability, displacement, and diversification. This is actually what I wanted to show. There are still some things that are puzzling, at least to me, and I have been discussing this with my colleagues, in particular with Stefan Hartmann, with whom I'm working on this final study. So one is that we know from George Sipp that actually more frequent words have more senses. So this is something that you can observe empirically. But for some reason, they do not get those senses. They do not have the tendency to get those senses over time. So there is an interesting mismatch between diachrony and synchrony. So it might be that words start obtaining more senses and then they become too frequent and then they stop obtaining, or a mechanism like this that one could look at. The other puzzling thing is that the population dynamic model actually predicts that this is because frequent words are optimized for easy transmission. But we also found that early acquired words are more likely to obtain more senses. So maybe then this prediction of the model does not really refer to transmission in first language acquisition, but only transmission in everyday communication. So probably it's a bad model if you look at first language acquisition, might be. So still a couple of things to think about. And finally, what I wanted to demonstrate, and this probably links to the Sadhana agenda, is that the use of digitized data and computational methods for quantifying meaning are great for testing hypotheses about the lexical development of words, both on the theoretical level and also on empirical level. And the great thing about all of these corpora databases is that they have data about lots of words. You do not need to restrict yourselves to single cases. It is always good to look at single cases. I do not say that this should be neglected, but the advantage is that you can cover thousands of words and base your theory on observation. All right, thank you.
Going a little bit over time, that's because we started. Okay, so there is a bit of time for questions. So if there are questions here in the room.
It's more of a comment.
Yeah.
This was 3 years ago, so it may have changed. 3 years ago, I spent time in Germany.
Yeah.
And I was told that the word lacquer can only be used with reference to food. Only food can be lacquer. But in France, we use lacquer with a much greater right. So, I was thinking that may also be interesting in future to look at these kinds of diversification.
Yeah. So cross-linguistic observations, this is, I mean, it's definitely a good point. So all of this is just based actually on 2 languages. And one would actually need to test all of this on a larger set of languages. But the sad story is, I mean, there is a lot of data for English, but not for a lot of other languages. I mean, I'm not talking about synchronic data. There is a lot of synchronic data available for a lot of languages. But when you look at language history, even for German, it's like a very sad story that you do not have a resource like the Corpus of Historically American English, which is a balanced data set, so balanced with respect to genre, with a large number of tokens. Yeah, and actually in Austrian German, one doesn't really use the word lecker, not even to refer to food, but I think this is changing. So it's a generational thing. So my daughter actually uses lecker. I don't know if I like it, but yeah.
Thank you, it was really interesting. I would like you to, I have a question on the slide of information.
Yeah. Oh, where is it? Oops, yeah, here it is. Yeah.
Yes, I find the other option that are quite interesting. And you're saying it's dependent on text. Can you maybe just elaborate a bit?
Yeah. We have so what this part here does is it measures the rate that's of one individual not yet using particular variants to adopt. It measures the rates that one individual not applying that variant adopts it from some other individual that this individual needs. So this is this part here. So this is
So that would be a lag.
Yeah. So we always, so what the model does is it looks at how often individuals speak. If both of them know the word already, then nothing happens. And if one of them doesn't know the word and the other one does, then transmission might take place. And it takes place depending on these 2 parameters here. So this is utterance frequency, and this is adoption. And we wanted to keep this separate from each other because this sort of measures how likely it is that an individual adopts the if this encountered once, just once, independent of frequency. So we take this out of this. And then the idea is that this rate of adopting a variant, the word, if you hear it just once, depends on the semantic point. Because I mean, we know that the lexico-semantics and, for example, the valence of the word influences how easy a word is processed. For example, for valence, we know that positive words are processed most easily. Negative words are also processed relatively easily, but neutral words have actually a disadvantage. So we have a shape like this for when you look at valence, and this is what this parameter tries to measure. But it's always only depending on a single semantic dimension. And of course, this is very abstract because the meaning of a word consists of multiple. But this is what this is about.
There are some questions in the chat. Carolina, perhaps you want to unmute? Can you hear me, Carolina?
Yes, I can hear you now. Yeah. Okay, so I will ask my question. Thank you, Andreas, for your presentation. My question concerns the process of semantic bleaching. A process understood as a situation in which a highly frequent word gradually loses its specificity and meaning and becomes more generalized. Yeah. So here I wanted to ask you if this high frequency in the case of these words, does it facilitate the semantic change or not? What is your view on that?
Yeah, this is a very good comment. It maybe depends on how you measure semantic bleaching, because if you say that semantic bleaching is the same as having a lot of meanings, so being very polysemous, then the prediction of our research would actually be that in contrast to what we know from grammaticalization research, semantic bleaching is prevented by high frequency. So this is an interesting contradiction. Maybe one needs to measure semantic bleaching in a different way, namely by not looking at how many meanings a word has, but to what extent it does not have any lexical meaning, but only some grammatical functions. And the thing is, with this approach here, we cannot really measure to what extent the word has a grammatical function. So all of this is actually only about lexical meaning. This might be the resolution for this contradiction. I'm not sure that does this answer your question.
Yeah, thank you for your answer. So I was actually thinking about that, like how we understand semantic bleaching and what is actually happening during that process may influence the answer to that question. So if we see it as a situation in which the word loses one part of the meaning, but then gains other different meanings, like you said, becomes polysemous, then yeah, probably your answer is logical and it makes total sense. So yeah, thank you. But then also some authors call semantic bleaching, like Jeffrey Hughes, verbicide. So the word actually loses its lexical meaning, like with luxurious, like luxury for everyone, right? So it's the lexical meaning being erased by the high frequency, because now everything is luxurious if it's for everyone. So I think it really does depend on how we see and perceive semantic bleaching. So I was just curious if you had any research on that.
Yeah, I mean the short answer is no. Yeah, the problem is I do not know to what extent these methods lend themselves to study semantic bleaching, because they are so much focused on constructing meaning in terms of lexical. Because when you try to measure meaning in terms of word embeddings, in terms of the which are ultimately based on the other lexical neighbors of the words, then immediately you always have a lexical component in this way of measuring, because by using word embeddings, there is literally no way of not looking at the vicinity to other words, lexical words. So my answer would be that you need a set of different methods to to investigate lexical
Yeah,
meaning.
I see, because it's more of a loss than yeah, if we look at it, yeah, more of a loss than emergence, or more of losing of the process of meaning loss than getting a new meaning. Yeah, so yeah, I understand. It sounds interesting though. Yeah.
Yeah, thanks for the question.
Thank you. Thank you.
Okay, thank you very much. I think we're running a little bit over time, partially because of the technical issues, but also because we're just running over time. But thank you very much for your very interesting presentations. Thanks. You were here, there is some. Thanks.
So trying to process it.